I'm Anil Kumar, and in this video we will learn how to represent absolute function as a piecewise function. So let's get into the very basics of absolute function. What we have learned here is that absolute value is always non-negative, right? So let's write down our concept, and that is absolute value is non-negative, right? That is the basic concept which we have learned. So what we will do is, based on this concept, we'll take up some values and we'll kind of make a table of values, correct? So let us take some values for x. So if I take values of x as, let us say, -3, -2, -1, 0, 1, 2, and 3, in that case, what is the absolute value of these? Absolute 3 minus 3 is 3. Absolute value of -2 is 2. For -1 it is 1. For 0 it is 0. For 1, 2 and 3 it is same. Correct? So using these values we can actually plot the graph, right? So for x values of 1, 2 and 3 we have the same x values. For 0, 1, 2 and 3 we have the same absolute value, so which is 0, and for 1 we can have 1. So we get a same line here, right? So if we are considering a line on the right side of y-axis, let us say this is our y-axis, this is x-axis, here we have 0. Then the line on the right side, as you can see here, is exactly same. So these values are matching. Do you see that? These values are matching. But what happens to the left side values? If I'm talking about -1, it becomes +1, so it comes here, right? And if I'm talking about -2, x value, it becomes +2. So what really happens is that it gets reflected on the x-axis. So what you see is kind of a graph as shown here, right? A V-shaped graph with vertex at origin, right? So we get a V-shaped graph with vertex at origin, right? This is what we get for absolute function, right? Now we could actually write this particular function, which we are saying y equals to absolute x, in the form of piecewise functions, right? So let us do that now in this particular video. So what we considered here is that it could be divided into two pieces, right? So we have this half which is on the left side where x value is less than 0, and then we have a half on the right side where x value is greater than 0. And let us include this point on the right side since it is non-negative, right? So what we see here is that if I draw a line y equals to x, let us say this is my line y equals to x, then on the right side the absolute value is same as x, right? It is same as x. When it is 1, it is 1. When it is 2, the value here is 2, right? So same as x. So we could write here that absolute value of x is x when x is greater than or equal to 0. Now, when you consider the left side, that is to say, when x is less than 0, in that case, each point on the line y equals to x is reflected on x-axis. So it is kind of minus of x, right? So we could write this part as minus of x when x is less than 0. So that is how we could actually represent the absolute function. Now these are two different pieces, and therefore we call it like a piecewise function. Do you understand? So that is the way to represent absolute function as a piecewise function. Now here is a thinking question for you. Let me say tips. You need to represent the given function as a piecewise function. The function now is kind of translated one unit to the right. Now if I give you this function, absolute value of x minus 1, how are you going to represent this as a piecewise function? You can pause the video, think about it, and then look into my suggestion. Well, let's try to do it. So in this particular case, what we really have is that the function here is translated 1 unit to the right. So what we could do is, we could actually translate this function 1 unit to the right and then say it should be kind of like that. Do you see that? Kind of like this. So that makes sense. That makes sense, right? So that is how the function could be. Now, how do you represent this as a piecewise function? So basically what you notice here is that on the right side of 1, it is kind of same as x minus 1, right? This line which we have here, this time is y equals to x minus 1. This line y equals to x has been moved 1 unit to the right. So we have graph of a line which is y equals to x minus 1. So what we see here is that it could be written as two pieces. The first piece, which is on the right side of 1, could be written as x minus 1. That is, when x is greater than equals to 1, right? And on the left side, it has been reflected. So it becomes negative of x minus 1 when x is less than 1. Do you see that? So that is how you can write absolute value of x minus 1 as a piecewise function. Did you get the idea, right? Now here, critical thing to understand is, let me show you what is a critical thing. It is the vertex. It is the vertex. What I'm trying to say is that point, this point. How do you get x greater than equal to 1 or less than 1? You get it from here. X minus 1 should be equal to 0. Do you see x? There's a point vertex on the x-axis. When you solve this, you get x equals to 1. So that is how we get our critical point. Do you see that? So when we say x is greater than equal to 1, we are trying to say that x minus 1 is greater than equal to 0, right? It's positive. That's the whole idea. So whenever you have a transformed absolute function, and if you have to write that as a piecewise function, try to find the vertex by equating the function to 0, right? So whenever that function is positive, then keep the function as such. Whenever it is negative, take negative of that. Reflection on x-axis. I hope that helps you to understand how to write any absolute value function as a piecewise function. I'm Anil Kumar. I hope you learn a lot from my videos. Thank you and all the best.